Good afternoon, everyone. My name is Picholo. My colleague here, Sampath, will be talking a little bit later. But we're glad to be here at API Summit. A couple months ago, my wife gave me a task to organize my kid's birthday, right? She actually said, you're in charge of doing the birthday. Here's a checklist of 15 items I needed to do to make sure we had a successful birthday. It was decorate, plan the food, entertainment, and what so forth. I was overwhelmed. I was like, what the heck? Why am I in charge of this? But I was looking for that easy button. You know what came to save me in this case? Chuck and Cheese. Oh my gosh, that place is awesome. It was instantly a place where we got the entertainment, we got the food, everything was done. Kids were happy. I think bottom line of that, on any type of this party, was the kids happy? Yes, they were happy. They loved it. They made memories. And we as platform teams, that's, I think, one of our goals is to make our developers' lives a little bit easier. Be able to provide that all-inclusive package at the platform level so that all they have to do is bring their code, allow them to just naturally deploy and make it easy for them. And so that's what the talk is going to be today. So how did we be able to kind of produce that all-inclusive package for our developers? So let's just jump to it. Who are we? We're a fashion retailer in the Pacific Northwest. We have over 350 stores. We have a digital presence, both on web and mobile apps. We have hundreds of API teams, as well as thousands of APIs themselves. Our typical normal business, we have 15,000 RPS. But what's unique about it is that at any moment, that number could spike 5 times during any sales events, shoe drops, any viral clips that go wild with our Nordstrom media. So what I want to kind of show you is what the architecture looked like 5 years ago for us and the issues of we used Apogee, a SaaS product. One of the main things that we ran into was that it couldn't scale fast enough for us, mostly during these sales events. We were constantly, anytime there was a spike in traffic, we had to constantly, we would get incidents and our APIs would be struggling, and then we would have to call Apogees like, hey, did you guys pre-scale like we told you? And they said no, or maybe they did and it wasn't good enough. And so we were running into a lot of the issues related to the Apogee scale. The other thing that we had issues was that each team, our applications teams, had to expose their services to the public internet since Apogee was on the public internet for us. And asking all these teams, these hundreds of teams, to make sure you lock it down properly, that was a big task for them to do. Lastly, at the service layer, we had all the different types of deployments for that. Our operations teams had struggled to understand how typically the routing worked, right? How we would ask the platform teams to look into the deployment strategy. It was very hard for them to detect the issues as well as repair issues if they come up. The effects cascaded to slow deployments, unpatched systems, and compounded technical debt. Previously, we also attempted to do a multi-region effort with this structure in place. And this was not easy to do. Every team did multi-region differently. Each team did health checking differently. Some teams didn't have failovers in place, and so we had to kind of come up with a way to help them through that. So this is the architecture that we were dealing with 5 years ago. And some of what I wanted to go now is to talk about how we kind of made steps to make it a little bit better. So back then, we actually set a set of goals. We had 2 sets of major goals. Fixing the past, as well as building the future. Related to goals that we were set to fixing the past, we wanted to implement zero trust. And this zero trust means never trust, always verify, not only for our public traffic, but for our internal traffic. We also wanted to make the platform be able to standardize, automate, and self-serve. We wanted to make it easy for our development teams to deploy their code. And also we wanted a platform to be able to enforce security policies by default. So building for the future, we wanted as a company to standardize on the cloud native. Specifically, we needed to containerize all our apps. And we had a large focus to go into Kubernetes. Related to, we couldn't, being cloud agnostic here, we didn't want to be tied down to one cloud provider, that we needed to have our abstractions work for AWS, GCP, Azure as well. And lastly, the big goal for us was that we needed to get our availability much higher to what it was before. We wanted no single point of failures. We wanted automatic failovers. We wanted to build a platform that was resilient at the platform level so that each of our application teams did not have to build it themselves. So one of the first steps that we did is that we introduced the Kong Gateway into our platform. So we got rid of Apogee as a SaaS product and actually built the Kong Gateway self-hosted here. One of the first benefits that we saw was that, one, we had control of the scalability. We were able to scale to the needs of our customers. From that, when we went to self-hosted, we saw that we weren't having any latency compared to Apogee as before. And so the businesses was able to be more aggressive on their promotions. The other thing that we instantly got a benefit of was the seamless observability integrations that Kong provided. We were able to send all the traces and metrics to the current dashboards that the app teams were already using. So they were able to see their API as well as their service side by side. And that was a huge benefit to be able to detect any issues as well as repair any issues of any struggling APIs. The other benefit that we saw right away was that going to a self-hosted is that our internal calls were truly internal now. We no longer had the internal services to exit out to the public internet to come back in. And so all we had to do as a platform is really protect our Kong Gateway. Let's see. So with this in mind, Kong going to a self-hosted Kong, this gave us the ability to do that zero trust with high availability to handle any spikes in traffic. And also, as part of this, and Sampath will talk about this later, is that deploying their app team's configuration, we were able to templatize all this for them. And it made it very easy for them to get a proxy as well as their service up pretty instantly. Next up, we'll talk about the other part, the Kong Ingress that we implemented.
Good afternoon, everyone. Thank you, Pachalo. Okay. As we started implementing the Kong Gateway, the next step for us was looking into our compute landscape. As we were looking into it, as Pachalo alluded before, having a fragmented compute options made it very difficult for us to provide a holistic, standardized experience for applications. With that, and also as our most of the applications were on the path of containerization, we leaned heavily towards Kubernetes as our default compute option platform. And with that, we exposed our app developers to the networking aspects of Kubernetes, which was like they had to deal with creating load balancers, setting up external traffic policies and everything which were complex and operationally intensive for them. So with that, we were looking for our good solution for Ingress Controller, and with our past experience of building Kong gateways, Kong Ingress Controller was our natural choice. And along with Kubernetes, along with Kong Ingress Controller, we also introduced lightweight NGINX Sidecar in the application pods to terminate TLS connections. It's it kind of feels that we can't have enough NGINX proxies before the request gets to the app. But this one, we believe, is worth it as our application teams are unburdened with the hassles of managing certificates and TLS connections. As a platform team, we were able to, with this pattern, we were able to automate all the certificate managements across the path, and this was a big relief for our application teams. Next up, we were looking into our service deployment process, and we were looking into service deployment processes, and we chose Argo to be a control, Argo to be the tool for our control releases. Yes. The best thing about this is that both Argo and Kong Ingress Controller are early adopters of Kubernetes Gateway APIs. Kong, in fact, is a major contributor for the open source Gateway API project. Let's see how this works. When there is a new deployment for a service, Argo creates a new set of pods for the deployment, and it also creates a HTTP route. This is how we implemented it. It also creates a HTTP route with an Canary header that can route the traffic that points it to the new deployment. Kong Ingress Controller automatically picks up this change in definitions, and it creates a Kong route that matches the Canary header, and it sets up a service, Kong service with an upstream pointing to the new deployments. At this point, the application teams can test their new deployments by passing the Canary header in their test requests, while the traffic, live traffic is still going to the original set of pods. This allows them to test it without any disruption to the live traffic. Once they have validated, Argo allows you to migrate the traffic in incremental steps. Overall, this provides an application team to confidently deploy their applications, test it before allowing the traffic, live traffic, and fail fast, revert fast in case of any failures. To achieve our goal of enabling our application teams to get to 4 nines availability, we were looking into our resiliency strategies. We had to be resilient against our regional failures as well as any major application failures. For that, we used Kong gateways and upstream objects to enable it. Kong gateway plays a very critical role, acting as a backbone for our routing layer in our multi-region strategy. We deploy Kong gateways in multiple regions in an active-active configuration, where the requests from the clients are routed to the Kong gateway that is nearest to the region of the client. This can be enabled by IP Anycast or IP Anycast like AWS Global Accelerator or GSLB, DNS-based GSLB solutions. All the services within the gateway are set up with upstream objects that have targets configured to route the traffic to both the region endpoints. The target weights are set up in such a way that the local region service endpoints are preferred. And also the upstream objects health checks are set up in such a way that any disruption in the health checks automatically are detected, and the traffic is routed to the alternate regions. In this case, if a request was coming from San Francisco in the west region, the request is routed through Kong Gateway in the west and lands in the Kubernetes cluster on the west side. In the similar fashion, a request coming from New York goes through Kong East Gateway and goes to the East Kubernetes. In case of any failures, the requests are automatically routed to the west. It also supports for different configuration modes for the application to be active-active as well as active-passive, or even a single region deployment. Overall, this pattern decreases the latency, keeping the request within the same region, as well as being able to shift the traffic in case of failures. It also keeps the costs down because we would be avoiding the cross-region overages. Now, something that makes all of this effortless and possible for us, for our developers, is the standard pipeline. This is an all-encompassing pipeline that automates, that we built and automates the build, testing, and deployment of applications, along with the gateway, Kong Ingress Controller, and the TLS Sidecar configurations. The deployments are self-managed by the application teams, and the guardrails implemented in the pipeline to make sure the engineering standards and security best practices are followed. In addition, the pipeline also automatically creates dashboards and alerts for the applications that are being deployed. Overall, it reduces the lead time to production by automating most of it, and about most of our applications get their pipeline set up with minimal set of inputs, somewhere around 10 to 15 inputs. Finally, this is our current state where we are, and we were able to build a resilient platform, actually chain of platforms that can support our application teams to achieve the goals of security, operational reliability, operational excellence and reliability. By having hardened Kong Gateway, we were able to get zero trust and reduce our public exposure, as well as the reliability features that we put into our platforms reduced mean time to detect and mean time to recover. For example, the service deployment changes that we did, as well as the observability is a big, added observability is a plus in this case. Overall, with this pattern, we were able to get 85% of our application teams adopting Kubernetes as the compute for their compute with and deploying through standard pipeline. Our future is mesh and is a long-term dream. which we are on the verge of realizing. We intend to support all the north-south traffic coming through the gateway, and that would be the inlet into the mesh. And most of the east-west traffic served by the mesh itself. We also intend to offload most of our multi-region routing capabilities onto the mesh policies. And I'd like to thank everyone for the time, and if open to questions right now, I guess.